Okay, students, now we will continue the vectors. Last class we have read what is vectors and dot product. Next we will discuss about cross product and vector product. So what is cross product? For any two vectors, a vector and b vectors, a cross b is defined to be ab sin theta n cap, where two vectors are a vector and b vector, and theta is angle between a and b vector. So this is nothing but the right handed screw system. So if we have a right handed screw system from OA, that is a vector, to b vector with some angle theta, then n cap is perpendicular to both the plane containing a vector and b vector. So this is just like a right handed screw system. So if we turn the screw in anti-clockwise, it is move upward direction. So we represent n cap which is away from the plane, that is perpendicular to a vector and b vector. So a cross b is equal to ab sin theta, where a is magnitude of a vector and b is magnitude of b vector. So next, magnitude of a cross b is equal to ab sin theta, where magnitude of n cap is equal to 1, because n cap is unit vector perpendicular to the plane containing both a vector and b vector. Next, n cap is nothing but a cross b divided by magnitude of a vector cross b vector. So as it is a vector quantity, so it is not commutative, that is a cross b is not equal to b cross a. So in the relation between a cross b and b cross a is called a cross b is equal to minus of b cross a. So vector cross product is not commutative. So if theta is angle between a vector and b vector, so if theta is equal to 0 degree or 180 degree, so sin 0 or sin 180 is equal to 1 is equal to 0. So that means a vector cross a vector is equal to 0 vector. Similarly, if theta is equal to 90 degree, sin 90 is equal to 1. So that means if represent in component wise, that is a vector is equal to a1 I cap plus a2 j cap plus a3 k cap, and b vector is equal to b1 I cap plus b2 j cap plus b3 k cap, where I cap, j cap, k cap are unit vector perpendicular along x, y and z axis. So if we have three axes, x axis, y axis and z axis, I cap, j cap and k cap are unit vector along x, y and z axis. Now if theta is equal to 0 degree, then sin 0 is equal to 0. So that means I cap cross I cap is equal to j cap cross j cap is equal to k cap cross k cap, each is equal to 0 vector. And if theta is equal to 90 degree, sin 90 is 1. So if we have a clockwise direction, that is I cap, j cap and k cap, so I cross j is equal to k cap. Similarly, j cross k is equal to I cap, but k cross j is equal to minus I cap. So, if we have in component wise, if we represent A cross B, that will be represented as in a determinant form I cap, j cap, k cap. First component of A vector, that is A1, A2, A3, B1, B2, B3. So, this is the component wise representation of a cross product. So, if we take some example, that is, say A vector is equal to 3 I cap plus j cap plus 2 k cap, and B vector is equal to I cap minus j cap plus 2 k cap. So, unit vector perpendicular to both A vector and B vector is n cap, which is nothing but A cross B divided by magnitude of A cross B. So, next, how to find A cross B? So, A cross B is equal to determinant I cap, j cap, k cap, and component of A vector is 3, 1 and 2, and B vector is 1, minus 1, 2. So, we can expand the determinant, that is I cap into 2 plus 2 minus j cap into 6 minus 2 plus k cap into minus 3 minus 1. So, which is equal to 4 I cap plus minus 4 j cap minus 4 k cap. Next, magnitude of A cross B is equal to root over of 4 square plus minus 4 square plus minus 4 square. So, which is equal to root over of 48. So, n cap will be A cross B, that is equal to taking 4 common I cap minus j cap minus k cap divided by root over of 18, that is equal to or root over of 48. So, that is n cap, which is perpendicular to both plane containing A vector and B vector. Next, the geometrical representation of cross product. So, how we define cross product geometrically? That is geometrically vector product. So, if we have two vectors, that is OA, A vector, and OB, that is B vector. So, and theta is angle between them, A vector and B vector. So, now if we draw perpendicular, that is BM, so BM is equal to B sin theta. Now, we join A and B. So, area of triangle OAB is equal to half base, that is OA, into magnitude BM. So, OA magnitude is equal to A and BM is equal to B sin theta, which is equal to half AB sin theta, that is nothing but half A cross B magnitude. So, area of triangle. So, geometrical representation of vector product is to find the area of triangle. Now, if we extend B vector along and A vector as C, then OA C B is a parallelogram and its area is equal to, and area OACB parallelogram is equal to 2 times area of triangle OAB. so which is equal to A cross B magnitude. So geometrically vector product is to find the area of rectangle, parallelogram or a triangle. If theta is equal to 90 degree, then OACB is a rectangle. If theta is 90 degree, so that is OACB is a rectangle, theta is 90 degree, and sin 90 is equal to 1. So A cross B is equal to AB. So area of rectangle is nothing but product of its length and breadth. The two sides, consecutive sides, are A vector and B vector. So next we consider the parallelogram OACB, that is OA B vector, that is B vector A vector. So this is parallel to C, both are parallel, that is B vector. So join this. So the OC is resultant vector of OA plus AC, that is equal to A plus B vector. And if we extend B vector in opposite direction, that will be minus B vector. And we join these two vector. So it will be A minus B vector. So it will be A minus B vector. So BA vector is equal to A minus B vector. So A plus B and A minus B are two diagonals of a parallelogram. Whose sides are A vector and B vector. Now, if we have A plus B cross A minus B, that is equal to A cross A minus A cross B plus B cross A minus B cross B, as A cross A and B cross B both are equal to 0 vector. So and B cross A is equal to minus A cross B. So that is equal to minus 2 times A cross B. So magnitude of A plus B cross A minus B is equal to magnitude of minus 2 times A cross B. So which is equal to 2 times of A cross B magnitude, as magnitude of minus 2 is equal to 2. So which is equal to half into A plus B cross A minus B is equal to A cross B magnitude. So what does it geometrically represent? So that means for a parallelogram whose two sides are, if A vector and B vector, so its diagonals are A plus B and A minus B. So if we consider another parallelogram, that is CD E F, whose consecutive sides are two diagonals, that is a plus b, a minus b, then area of CDEF is equal to 2 times area of OACB. So that means if we take two diagonals as two sides of a parallelogram, new parallelogram, so its area will be twice of the original parallelogram. So one of the geometrical application of cross product is to find area of parallelogram or area of triangle. So we take an example. Suppose a triangle having its three sides, that is A 0, -1, 2, B 4, 3, 1 and C 3, 2, 4. Then how to find area of triangle ABC? So you can make a rough diagram, that is A B C, and put its coordinate, that is 0, -1, 2, B, that is 4, 3, 1 and C, which is 3, 2, 4. First we calculate the two consecutive sides BC and BA having common vertex B. So BC vector is equal to component wise, if you write, that is 3 minus 4, 2 minus 3 and 4 minus 1. So that is equal to -1, -1, 3. Similarly, BA vector is equal to position vector of A minus position vector of B. So that is equal to 0 minus 4, -1 minus 3, 2 minus 1. So that is equal to -4, -4, 1. So area of triangle is equal to half into BC cross BA as two consecutive sides. So that is equal to half magnitude of the determinant, first I cap, j cap, k cap. BC component wise is -1, -1, 3, -4, -4, 1 determinant. So that is equal to half determinant magnitude of I cap into -1 plus 12 minus j cap into -1 plus 12 plus k cap into 4 minus 4. So that is equal to half into magnitude of 11 I cap plus 11 j cap. So which is equal to half root over of 11 square plus 11 square, which is equal to half root over of 2 into 121, 2 into 11 square, which is equal to half into root 2 11, that is equal to 11 by 2 root 2 square units. So this is to find out the area of triangle having the three vertices. So we can take another example to find the area of parallelogram. Suppose we are given two diagonals of a parallelogram are 3 I cap plus j cap plus 5 k cap and 7 I cap minus 3 j cap plus 9 k cap. That is the two diagonals of a parallelogram. Now to find the area of parallelogram. So if let A vector and B vector be two sides of parallelogram. That is, two sides are A vector and B vector. Then its diagonals are A plus B and A minus B. So A plus B is equal to 3 I cap plus j cap plus 5 k cap, and A minus B is equal to 7 I cap minus 3 j cap plus 9 k cap. Now if we solve these two equation by adding these two, we have 2 A cap is equal to 10 I cap minus 2 j cap plus 14 k cap. So A vector is equal to 5 I cap minus j cap plus 7 k cap. Similarly, by subtracting B vector, 2B vector is equal to minus 4 I cap plus 4 j cap minus 4 k cap. That is, V vector is equal to minus 2 I cap plus 2 j cap minus 2 k cap. So area of parallelogram is equal to magnitude of A cross B, or you can directly, without finding A vector or B vector, or you can find out that is equal to half of magnitude of A plus B cross A minus B. That is, without finding these two sides, we can directly find the cross product of these two vectors. So that is equal to I cap, j cap, k cap, and A vector is 5 minus 1 7, and B vector is minus 2 2 minus 2. So which is equal to I cap into 2 minus 14 minus j cap into minus 10 plus 14 plus k cap into 10 minus 2, its magnitude. So that is equal to magnitude of minus 12 I cap minus 4 j cap plus 8 k cap, which is equal to root over of minus 12 square is 144 plus 4 square is 16 plus 8 square is 64. So which is equal to root over of 224 square units. So this is one application of a cross product to find the area of parallelogram. Next we take another example of cross product is Lamy's theorem, that is sine law. So sine law is A by sine A is equal to B by sine B is equal to C by sine C. So this is Lamy's law. That is, in a triangle, suppose ABC is a triangle, and face of A is A vector, face of B is B vector, and AC is C vector. So we take the three vectors in a cyclic order. So obviously that is sum of three vectors in a cyclic order is 0 vector. So A plus B plus C is equal to 0 vector. So A plus B is equal to minus C vector. Now if we take the cross product A plus B cross B vector minus C cross B vector. So this is equal to A cross B plus B cross B and minus C cross B is equal to B cross C. So vector product is not commutative. So that is minus C cross B is equal to B cross B, and B cross B is equal to 0 vector. So this implies A cross B is equal to B cross C. Now if I take the magnitude of both sides, so A cross B magnitude is equal to B cross C magnitude. Now between A and B vector, we take in a anti-clockwise to extend A vector, then the angle between A vector and B vector is pi minus C vector, because this is your C vector, C angle C. So this angle is pi minus C. So similarly, B vector and C vector, the angle is extend B vector, and this is A angle A. So obviously this angle is pi minus A. So that is equal to A B sin pi minus A is equal to B C sin pi minus C. So B cancels out both sides. So this implies A sin A is equal to B sin C. So that is A sin pi minus C and pi minus A. So A sin C is equal to B sin A. So A by sin A is equal to C by sin C. So this is equation 1. Similarly, if we take B to the right hand side, that is A plus C is equal to minus B, and C vector, that is C cross A plus B C is equal to minus C cross B. So this is C cross A plus C cross C and minus C cross B is equal to B cross C, and C cross C is equal to 0 vector. So C cross A magnitude is equal to B cross C magnitude. So C cross A is your C vector and A vector. This angle is pi minus B. So that is CA sin pi minus B, and BC is BC sin pi minus A. So C cancels out both sides. So A sin B is equal to B sin A. So A by sin A is equal to B by sin B. So this is from 1 and 2 we have A by sin A is equal to B by sin B is equal to C by sin C. So this is your Lami's theorem. So this is one of the applications of vector product. So we have dot product and cross product of two vectors. Next we will discuss about product of three vectors. So if A vector, B vector and C vector are three vectors, suppose A, B and C are 3 vectors. Now, what is the 3 vectors product? One is your scalar product. And other one is vector triple product. So, first of all, we have scalar triple product. So, scalar triple product is the product is a scalar quantity. So, that is A dot B cross C is a scalar triple product, because B cross C is equal to A dot B cross C is B C sin theta n cap, where theta is angle between B vector and C vector, and n cap is unit vector perpendicular to both B vector and C vector. So, if we take the geometrical interpretation, that is B vector and C vector, angle between them is theta. So, this is your BC sin theta. N cap is unit vector perpendicular to both B vector and C vector. Now, next it is equal to BC sin theta is a scalar quantity, we take it outside, A dot n cap. Now, A dot n cap is equal to BC sin theta. A dot n cap is equal to A n cap magnitude into cos phi, where magnitude of n cap is equal to 1. So, that is equal to A B C sin theta cos phi. So, this is equal to, this is nothing but A dot B cross C. So, what is phi? Phi is angle between A vector and n cap. So, A vector is something like, it is a 3-dimensional concept. So, if you take a rectangular parallelepiped and join these sides, so this is A vector. So, angle between A vector and n cap is phi. Theta is angle between B vector and C vector. So, this is O A B C D E F G. So, it is a rectangular parallelepiped having 3 consecutive sides, B vector, C vector and A vector. So, B, C and A are not in a plane. So, we have A B C, A dot B cross C is called A B C sin theta cos phi. So, next we find out its component wise, how to find its component wise. Suppose A vector is equal to A1 I cap, A2 j cap plus A3 k cap. B vector is equal to B1 I cap plus B2 j cap plus B3 k cap, and C vector is equal to C1 I cap plus C2 j cap plus C3 k cap. Now, B cross C is equal to determinant I j k, B1, B2, B3, C1, C2, C3. So it is a vector quantity. So we can represent it is, that is, B cross C is a vector quantity, that is. Now A dot B cross C, it is a scalar quantity. Now replace the unit vector I cap, j cap, k cap by component of A vector. So component of A vector is A1, A2, A3. So this is nothing but A1, A2, A3, B1, B2, B3, C1, C2, C3. So in component wise we can express A dot B cross C is equal to, it is the determinant first A vector, that is A1, A2, A3 component, then B, then C, and A dot B cross C is equal to ABC sin theta cos phi. So where theta is angle between B vector and C vector, and phi is angle between A vector and n cap. Now what is its geometrical significance? So B cross C magnitude is area of parallelogram of sides B vector and C vector. So this is the area of base. So B cross C magnitude, which is equal to BC sin theta. Now A dot n cap is equal to A cos phi, which is projection of A vector on n cap, that is projection of A vector on n cap, that is nothing but, which is perpendicular, which is altitude of parallelepiped. So area of base into altitude is nothing but volume of parallelepiped. So geometrically scalar triple product is the volume of parallelepiped. O, A, B, F, E, D, G, C. So this volume of parallelepiped is its scalar triple product. Now you know that scalar product is commutative, that is A dot B is equal to B dot A. So A dot B cross C is equal to B cross C dot A, as scalar product is commutative. So A dot B cross C is equal to B cross C dot A. Now if you rotate the parallelepiped, suppose the base is C and A, so it will be B dot C cross A. So C and A are two base, so which is equal to C cross A dot B. And if A and B are two base, so that is C dot A cross B is equal to A cross B dot C. Now, these 6 quantities are equal. So, if we consider this is a duster, and if we move the duster in different directions, the volume will always remain the same. So, whatever will be its orientation, volume is remaining the same. Similarly, for this parallelepiped, what will be its rotation base, the area is volume is always remaining the same. So, all these 3 quantities are equal. So, that means another most important factor is the scalar triple product in scalar triple product is independent of position of dot and cross. So, it does not depend upon dot and cross. So, that means it does not depend upon dot and cross. So, that means here we have A dot B cross C and here it is A cross B dot C. So, it does not depend upon the position of dot and cross. So, that means we can represent A dot B cross C as simply a square bracket A B C. So, first quantity is equal to A B C, first quantity is A B C, the next one is B C A, and the third quantity is C A B, and all these are equal. So, that means in a scalar triple product is independent of position of dot and cross. So, A B C is equal to B C A is equal to C A B, as long as it is in a cyclic order, A vector, B vector, C vector, that is in cyclic order. So, that means A B C is equal to B C A is equal to C A B, and if we take in a opposite direction, so obviously this is equal to minus C B A. It is in clockwise direction, it will be negative sign. So, scalar triple product is defined to be ABC, component wise is component of A vector, that is A1, A2, A3, B1, B2, B3, C1, C2, C3, and also ABC is equal to ABC sin theta cos phi. So, the next question is, if theta is equal to 0 degree or 180 degree, sin theta is equal to 0. So, that means if two vectors are parallel or equal, scalar triple product is 0. That means A vector, B vector, B vector is equal to 0, scalar quantity. So, two vectors are equal. So, scalar triple product is 0. Similarly, if phi is equal to 90 degree, cos phi is 0. So, phi is angle between a vector and n cap. So, if phi is 90 degree, so this is phi is 90 degree means a vector is along. So, then a vector is on the plane of b vector and c vector. So, that means 3 vectors are, that is 3 vectors are coplanar. So, scalar triple product is 0 if 2 vectors are equal or parallel, that is 0, or 3 vectors are coplanar. And scalar triple product is nothing but volume of rectangular parallelepiped. So, we can take some problems of scalar triple product. So, take one example, that is volume of parallelepiped. Having 3 consecutive sides. Say 2 I cap plus j cap plus 3 k cap, I cap plus 2 j cap minus k cap, and 3 I cap plus j cap plus 4 k cap. So, the volume of parallelepiped having 3 consecutive sets. So, suppose first one is a vector, that is equal to 2 I cap plus j cap plus 3 k cap. B vector is I cap plus 2 j cap minus k cap, and C vector is equal to 3 I cap plus j cap plus 4 k cap. So, suppose its 3 sides are a vector, b vector and c vector. Then volume is equal to scalar triple product of a, b, c, which is equal to determinant coefficient of a is, that is 2, 1, 3, b is 1, 2, minus 1, and c is 3, 1, 4. That is equal to 2 into 8 plus 1 minus 1 into 4 plus 3 plus 3 into 1 minus 6. So, it is always positive quantity. So, that is equal to 18 minus 7 minus 15, its magnitude always positive quantity. So, that is equal to 18 minus 22, that is equal to 4 cubic unit. So, if 3 consecutive sides are given, then we have to find the volume of parallelepiped. So, we can take one more example. Which is commonly asked in your exam, that is a plus b, b plus c, c plus a is equal to 2 times a, b, c vector. So, we can prove by taking from LHS, that is a plus b, b plus c, c plus a, scalar triple product. which is equal to A plus B. We can take dot or cross between any two, that is A plus B dot B plus C cross C plus A. So, which is equal to A plus B dot, we can expand this, that is B cross B, B cross C plus C cross C plus B cross A plus C cross A. Now, C cross C is equal to 0 vector. So, which is equal to A dot B cross C plus A dot B cross A plus A dot C cross A plus B dot B cross C plus B dot B cross A plus B dot C cross A. So, we can represent it as A B C plus A B A vector scalar triple product plus A C A vector plus B B vector C plus B B A vector plus B C A vector. Now, out of these 6 quantities, these parts are 0, this is 0, this is 0 and this is equal to 0. So, which is equal to A B C plus B C A. Now, if we take it in a clockwise, A B C is equal to B C A. So, B C A is equal to A B C. So, this is equal to 2 times A B C vector. Thank you.